Nuclear reactors are complex systems designed to harness the energy released through nuclear reactions, specifically nuclear fission. The working system of a nuclear reactor involves several key components and processes. Let's go through them. Fuel. The reactor uses fuel in the form of enriched uranium or plutonium, typically in the form of ceramic pellets. These fuel pellets are contained within metal fuel rods, which are assembled to form fuel assemblies. Moderator. The moderator is a material that slows down the fast-moving neutrons produced during fission, making them more likely to cause further fission reactions. Common moderators include water, graphite, and heavy water, deuterium oxide. Control rods. Control rods are inserted into the reactor core to regulate the nuclear reaction by absorbing excess neutrons. These rods are made of materials like boron, hafnium, or cadmium, which have a high neutron absorption capacity. Reactor core. The core of the reactor contains the fuel assemblies and moderator. It is where the nuclear fission reactions occur. The fission of uranium or plutonium nuclei releases a large amount of energy in the form of heat. Coolant. The coolant circulates through the reactor core, absorbing the heat generated by fission reactions. Common coolants include water, liquid sodium, and helium gas. The heated coolant is then used to produce steam in a separate system. Steam generator. The steam generator transfers the heat from the coolant to water, producing high-pressure steam. This steam is used to drive turbines, which are connected to generators to produce electricity. Control system. The control system of a nuclear reactor regulates the power output and maintains the reactor in a stable state. It includes control rods, which can be adjusted to control the number of neutrons and, consequently, the rate of fission reactions. Safety systems. Nuclear reactors incorporate multiple safety systems to prevent accidents and mitigate the consequences in case of emergencies. These may include emergency shutdown systems, containment buildings, and backup cooling systems. The nuclear reactor operates in a self-sustaining chain reaction, where the fission of one nucleus releases neutrons that can cause the fission of other nuclei, resulting in a continuous release of energy. The control rods are used to maintain the reactor at a steady power level by absorbing excess neutrons and preventing an uncontrolled chain reaction. It's important to note that there are different types of nuclear reactors, such as pressurized water reactors (PWR), boiling water reactors (BWR), and advanced reactor designs like molten salt reactors (MSR) or fast breeder reactors (FBR). Each type has its own specific design and working principles, but they all operate based on the fundamental concept of controlled nuclear fission to produce heat and generate electricity.